Alright, hello and welcome everyone. In this particular section of video, we'll be studying about the formation of phosphodiester bond and what is phosphodiester bond. So, phosphodiester bond is the basic bond or the basic entity of the life form because it joins the two nucleotide. Right? Nucleotide means, what is nucleotide? Nucleotide means sugar plus base plus phosphate, right? And nucleoside means sugar plus base without phosphate, right? So sugar plus base will be attached, like it will be sugar plus base, they will be attached by a phosphate. Alright, another phosphate, sugar plus base. Now, sorry, let me draw it more properly. Sugar plus base, sugar plus base, sugar plus base. Now, this bond, they will be bonded by phosphate. There will be phosphate in between them and they will be linked with one another, and this is ester bond and this is ester bond, and the two ester bond, they make a phosphodiester bond. Alright, why is the phosphodiester bond important? Because the nucleotide which is the main constituent or the main the factor of the life form, that is DNA and RNA, they are made up of sugar, phosphate and base. DNA is made up of sugar plus phosphate plus base, right? RNA is also made up of sugar plus phosphate plus base, and they are the basic unit of the life form. So we need to know how this sugar, phosphate plus base is forming a bridge between them and they are forming a unit of a life, right? So how is the DNA forming? Sugar plus base and the phosphate, they will be linked with one another in a series. These form, they will be of millions and millions length, like millions and millions kilometer in length. Like it is said that when we stretch our DNA, then it is so long in the land that it can reach till the sun, right? So in this, with the help of this bond, they are attached with one another and they are forming a very long stretch, and that long stretch will be coiling and supercoiling, and they will be forming a chromosome and they will be condensing inside a nucleus, right? So when one sugar will bond with another sugar, they will be linked by a phosphate in both the side, right? Here phosphate and sugar, and here also phosphate and sugar, and this bond between phosphate and sugar is known as one ester bond, and another bond between phosphate and sugar is the next ester bond, and the two bond, they are making phosphodiester bond. Means one molecule of sugar and base is joined with the another molecule of sugar and base with the help of one phosphate by two ester bond, that is known as phosphodiester bond. Done. Now drawing the diagram of the chemical structure of the sugar. Alright, this is known as, this is structure, since there are 5 sides, 1, 2, 3, 4 and 5, this is known as pentose sugar. This is known as pentose sugar. Now why is the RNA known as ribonucleic acid and DNA known as deoxyribonucleic acid. This is because see here this is 1, all right, this is 2 prime, 1 prime, 2 prime, 3 prime, 4 prime, and one stretch will be there. This is 5 prime. All right. Now what happens is, in this place, in case of RNA we are having OH, but in case of DNA we are having only H. Since the DNA is lacking 1 oxygen in the 2 prime carbon, so the DNA is known as deoxy, means it is deprived of 1 oxygen. All right, in 2 prime carbon. Deoxy means in the 2 prime carbon it is deprived of 1 oxygen, whereas the RNA, it is known as ribonucleic acid because it has OH in 2 prime carbon. All right, now let's talk about DNA only in this particular thing. So while drawing a sugar, how can you draw sugar? We can draw sugar by, see, you can make a insect kind of structure and you can enjoy making sugar, right? Okay, I prefer making this kind of structure because I can enjoy making sugar. See, it is looking like some kind of insect. Here are 2 legs and here are 2 legs, here are 2 legs, right? So what I am doing is, here I will be having OH, here I am having H, here I am having H, here also I am having H, here I am having H, and here I am having OH, here I am having H, and here I am having CH2OH. Alright, now how they are forming a pair is, we know there are 5 nucleotide base, right? Nitrogenous base, sorry. Adenine, guanine, cytosine, thymine, and in case of RNA we have uracil, right? So now these will bond, these bases will be bonded over here. 1 hydrogen will be removed when the bases they bond with the sugar. Now for example, this is adenine, base of adenine. So they are bonded with one another by glycosidic bond. And then now coming to this part. Here first, while taking phosphate group, all right, how does this phosphate it comes? Phosphate comes from the phosphoric acid, that is H3PO4. All right, if I draw H3PO4, how will it look? O, here will be double bond, here will be H, here will be H, and here will be H. All right, this is the structure of phosphoric acid. Now if I remove hydrogen, all the 3 hydrogen, then what can I write? Minus, 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 right? In place, as the hydrogen is positive, while replacing the hydrogen I need to add the negative sign over here. So what, now let's see how the phosphodiester bond is formed. Now this is phosphate, OH, 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 double bond O, right? Now what happens is, there will be water will be removed, H2O will be removed. There will be the process of condensation. All right, that is the formation of water, and then the bond will be left. In the next portion also I am drawing over the next sugar molecule over here. For example, all right, now let us draw another leg. First let us draw the legs. All right, and then here I have to draw only H, here OH, here H, here H, here H, and here CH2OH again. And now I am also again having phosphate here. Now another phosphate will be coming over here, right? Because these two need to be attached by the phosphodiester bond. Now here I am having another amino acid, for example guanine. All right, now another phosphate will come, then these will have OH, and this will have OH, this will have O only double bond, and this will have OH again, right? And from here the water molecule will be removed, and from here also the water molecule will be removed, right? So what is left now? What is left now? Let us draw the leftover part. Alright, for simplification I am drawing it in this way. O, P, double bond O, let's write minus over here, let's write O, then H2C, and then O and H. Alright, now can you see the formation of phosphodiester bond? Can you see? This part and this part is joined by a phosphate, and this part and this part is also joined by a phosphate. Two ester bond, hence making a phospho ester bond. Got the thing? And up also. For the next one, the up there is next sugar again. So we have CH2, and then we have O, right? Here also there is a formation of ester bond, and here also one ester. Here also phosphodiester. In the same way, this will continue. Again, here also there will be formation of one ester, and then again phosphate, and then again another ester. Here also phosphodiester. Got the thing? See, and we know that the pairing, and I think you must know the pairing, that there will be the hydrogen bond and then there will be the another sequence, because it is a DNA is having two helix at once. But let us not discuss that, only let us concern on the phosphodiester bond. First of all, what we studied is from this to this. First of all, what we studied is our DNA or RNA. It is made up of phosphate, sugar and base, and they are known as nucleotide. When we exclude the phosphate part, only when we take the sugar and base, it is known as nucleoside. So two nucleoside will be attached to one another with the help of a phosphate group. This is one nucleoside, sugar and base. This is sugar and this is base. These are one nucleoside, and these one nucleoside will be attached to one another with the help of phosphate, and this is again another nucleoside, and these nucleoside will be attached with one another with the help of phosphate, right? And in this way they will form a bridge. And how does the bond is formed, and how is the bond form is there will be the release of the water molecule when the phosphate will bind to the nucleoside, right? And there will be the release of not one water molecule, but at each time at the when the two molecule of sugar and when the two nucleoside, this is one nucleoside and this is another nucleoside, when the two nucleoside will bind with one another, then there will be the release of two water molecule, and with the release of each water molecule there will be the formation of ester bond, two ester bond. That is why the bond is known as phosphodiester bond, right? These particular bond will be happening in each of the, it will be formed between each of the nucleoside, and in this way they make a chain, right? They make a chain of the nucleic acid. All right, and the sugar and the base, they are attached to one another with the help of a glycosidic bond. All right, this was only for today. Thank you. If you like the video, you hit the like button and subscribe to my channel for more video like this. Thank you.